Welcome back to part 2 on trigonometric equations. Let's look at cosine squared of x equals 1/4. I want to mention that it's important to keep your interval in mind when you're calculating these, because sometimes it will say give all the solutions and sometimes it will say give the solutions between 0 and 2 pi, or maybe 0 and 4 pi. Now let's take a look at cosine squared of x equals 1/4. I'm going to take the square root of both sides. You could also bring the 1/4 over, set it equal to 0, and factor. Each one is a completely legitimate way of doing this. Remember that when you take an even root of both sides, you have to provide a plus or minus sign in front of your solution on the right. That gives me cosine of x is equal to plus or minus 1/2, and then from there I can find all my solutions. Here's my unit circle, and so I'm going to break it at positive 1/2 along the horizontal axis and at negative 1/2 along the horizontal axis. At this point, I hope you're seeing that there is an interesting relationship between the opposing terminal points, because they are exactly 180 degrees or pi radians apart from each other. This is going to be very convenient when we calculate the angles. If I want to find my x values, or my angles, notice x is holding the place of the angle measure in the cosine function. I will have x is equal to cosine inverse of negative 1/2, and x is equal to cosine inverse of positive 1/2. So let's list all the possible options. For cosine inverse of negative 1/2, we will have a radian measure of 2 pi over 3. And also, if we take pi and add pi over 3 to it, we will also have an answer in the third quadrant. So pi takes me to here, and then another pi over 3 would give me 4 pi over 3. For the positive angles, we would have pi over 3, and also we would go all the way around to 2 pi and then subtract pi over 3. Which would give me 5 pi over 3. Now, if you're still struggling with that just a little bit, think of 2 pi being over 1, multiplying the numerator and denominator by 3, which would give me 6 pi over 3, equivalent to 2 pi, remember, and then minus the pi over 3 would give you 5 pi over 3. If I wanted to represent all solutions, I could say that pi over 3 plus pi k will give me all solutions of the two angles that are exactly 180 degrees apart from each other, or pi, and then the other two angles would be 2 pi over 3 and 5 pi over 3. And I could just list 2 pi over 3 plus pi k. So it depends on whether you're asked for just one period of the function or the whole thing. So let's think about it as an actual equation or function on a xy axis. We have cosine for an interval between 0 and 2 pi. And now we're looking for where values that are equal to 1/2 and values that are equal to -1/2. And you can see again that there are 4 places where that occurs. In example B, we have sine x equals 2/7. We do recall, hopefully, that sine of x is opposite over hypotenuse, which should be able to help us. If we know that the 2/7 represents a height, we should be able to look at this and say, okay, well, I can mark this 3, 4, 5, 6, 7. There's my rather rough sketch of what these units might be. So 2/7 is right here. 2 of the 7ths up the unit circle. And we can see that the horizontal line will hit in 2 places, in the first quadrant and the second quadrant. And so I could also sketch this as a function for sine, where I have 0 at the beginning, 2 pi at the end, and I'm looking at (2/7), which is only in the first and second quadrant along the x-axis as well. So either way you look at this, it's still going to give you the same values out. You just have to keep track that sine of x is like your y, and cosine of x is like your x. Now, I need to figure out what this angle will be in the first quadrant, and then once I have that, then I can just subtract that angle from pi, and that will give me my other angle in the second quadrant. And that would also give me my values along the x-axis, because the point at which sine crosses from positive to negative is pi on a standard period for sine. I know my opposite side is 2, my hypotenuse is 7, and so I can just take sine inverse of 2/7, and that will give me a radian measure. So let's do that now. Sine inverse of 2 divided by 7 equals 0.29 radians. That is one of my solutions, but remember I also have this additional solution in the second quadrant. So I can also say that this is equal to pi minus 0.29 radians, because I have to think about how far it is from the horizontal axis, or 0 radians, up to this terminal point here along the outside arc of the circle, and then compare that with how far I would have to go to get all the way to this next point. If I get to just there, the remainder is that same radian length in the second quadrant. So I can go all the way to pi and then just subtract that little piece, that 0.29 radians. And that gives you the other value, which I think is pretty cool. Now let's do sine of x equals -2/7. That means that I'll be looking for values in the third and fourth quadrant of my unit circle. There's my unit circle. There's my unit circle. And now it's not very round. And now I'm going to figure out where negative 2/7 would be. I'm just going to break this approximately into sevenths. 1, 2, 3, 4, 5, 6, 7. 7 steps down. Now I'm supposed to be calculating negative 2/7. So that's along this y equals negative 2/7. If you want to think about it like that, it's a horizontal line cut at that point. And now I need to figure out what my angle will be to get to those values in the y direction. I'll go ahead and draw the arc that will give me my radian measure. Notice that I will have something larger than pi to give me this angle here in the third quadrant. Now let's calculate what sine inverse of negative 2/7 will be. I can see that my radian measure is negative 0.29. That means that I'm going in the clockwise direction, and this angle right here, to get to this point, this pink point that I've highlighted here, is going to be a measure of negative 0.29 radians. This is helpful because I can calculate the positive angle now by simply saying that sine of x equals negative 2/7 when the angle x is equal to 2 pi minus 0.29 radians. That will give me the full distance around the circle. And now you need to think about the other option, which is, what do I do for this side or angle in the third quadrant? Well, to get halfway around the unit circle, we would stop at pi. And if I want to get past that little additional part, we know that that's negative 0.29 radians in the fourth quadrant. So we could add 0.29 radians to pi, and that will give us our other angle. Pi plus 0.29 radians. Now, I don't know which way is going to work best for you to think about this, but somehow you're going to have to sketch this circle or a sine curve off to the side so that you can anticipate where to add and where to subtract your radians to get the final angles that work. Recall that cosine of x equals 2/7 means that we are looking for x values that are positive. So I'm going to break this unit circle in the x direction up into sevenths. That's approximately sevenths, and I'm looking at 2/7, so that will be right about here. X equals 2/7. Now remember, I am looking for horizontal change of 2/7. I'm not looking for the angle yet. I will be in a second. So don't get too confused by the fact that I keep saying x and y equal 2/7. It's how far in the x direction, so the horizontal shift away from the origin of 2/7. And now we need to figure out what that angle is to get to a horizontal change of 2/7. What's the radian measure for that? It looks like it's going to be more than 1 radian to get there. If I want to know what that radian measurement is, I just take cosine inverse of 2/7. Now recall that if I know this distance as an arc or a radian measure, an angle, then I can figure out that 2 pi is the total angle around the whole circle, and I can just subtract this angle I find from 2 pi, and that will give me the angle in the 4th quadrant. Cosine inverse of 2/7 gives me 1.28 radians. Now remember, that made sense because I said it looked, from drawing the unit circle, it looked like my radians were going to be greater than 1, which is good. 1.28 radians means that if I take that as one of my solutions, the other one will be 2 pi minus 1.28 radians. In this last one, we have cosine of x is equal to negative 2/7. That means we're looking at values along the horizontal axis that are negative. Again, I'll break this up into sevenths and then mark off at negative 2/7. I'm looking for the angle that will produce a horizontal shift to the left of 2/7. And I can do that by finding the angle in the 2nd quadrant or the 3rd quadrant. They will both give me values that are negative 2/7. I can find one of those angles by taking cosine inverse of negative 2/7. And that gives me 1.86 radians. That means that if I travel along the outside edge of my unit circle, I have traveled 1.86 radians. And if I want to figure out the other angle, I need to figure out how far I'd have to travel all the way around, possibly, before I could subtract that 1.86 radians and get the other angle. So let's think about how that would look. If I travel around the entire circle, I want this angle here, the one in brown. I want this angle that would be provided in the 3rd quadrant. But that means I need to go all the way around to 2 pi, and then I need to subtract this radian measure that I found previously. That means 2 pi minus 1.86 radians will give me this angle in the 3rd quadrant. So I have two answers once again to this equation. X is equal to 1.86 radians, and x is equal to 2 pi minus 1.86 radians.